Hello everyone and welcome back to our videos. Today we will talk about turboprop and turboshaft filters or separators. Also we will talk about the anti-ice system on turbine engine. Prevention of foreign object damage is a top priority among turbine engine operators and manufacturers. So we have methods that used to prevent the foreign object damage, and we will start on turboprop engine. We have three methods. The first one, inlet screen. The second one, movable vane, and the last one, sand or ice separator. The first method, inlet screen. It's one of the easiest ways to help prevent the foreign object damage, and it's an inlet screen over an engine's inlet duct. The inlet screen are seldom used on high mass airflow engine because icing and screen failures can cause serious damage. The second one, the movable vane. This method used a deflector vane. When this deflector vane extended, it will try to throw air to go inside the engine and let the debris or the foreign object damage to go outside of the engine. The third method that used is the sand or ice separator. This another device that help prevent foreign object damage, and it includes a basic design that consists of an air intake with at least one venturi and series of sharp bends like these bends. The venturies and the bend is used to accelerate the flow of incoming air and debris, so the debris has enough inertia that cannot follow the bends in the intake. This allows sand particles and other small debris to be channeled away from the compressor. Now we will talk about the turbo shaft filters or separators. We have two types, particle separator as we said in the first one, and here the swirl chamber filter. One of the most critical aspects of air inlet system design for the turboshaft engine is the prevention of the foreign object damage to the compressor. This is especially difficult in helicopter. So many helicopters are fitted with particle separator and another type that use several individual filter elements and act as a swirl chamber. So we talked about this when we talk about the turbo propeller. Now we will talk about the second one and called swirl chamber. In a swirl chamber we have so many filters in this hollows, so the air will go from this area and the filtered air will goes from the other side to the compressor of the engine. Inlet anti-ice system, and this it will be the last topic we will talk about it today. When turbine engine flies through ice condition, ice build up in the engine duct and the inlet guide vents. This disrupts the airflow into the compressor and reduces the engine efficiency. So, how to prevent the accumulation of ice? To prevent the ice formation, turbine inlet duct equipped with anti-icing system. It's ducted high bleed air temperature from compressor to the air inlet. The disadvantage of the bleed air from the compressor engine power output decreases. The decreased power output indicated by the rise in the exhaust gas temperature indicator and the shift in the APR engine pressure ratio and fuel flow. To avoid power losses, electrical system used. With an electrical anti-ice system, electric heating elements are embedded in a rubber boat or placed behind a metal leading edge surrounding the intake, and this will help to prevent the ice.